right, let's talk about one of the most important tools in your entire Python toolkit, the list. Seriously, you can think of it as the Swiss Army knife of data structures. If you're going to build anything cool or complex in Python, you absolutely have to get comfortable with lists.
So, think about this for a second. In pretty much any program you write, you need to deal with collections of things, right? A list of usernames, a bunch of temperature readings for the week, the steps in a recipe. The big question is, how do you wrangle all that stuff? How do you hold on to it, organize it, and, this is the most important part, change it on the fly? Well, that is the exact problem that lists were born to solve.
Okay, so we know what they're for, but what is a list really? Like, what's its DNA? Before we start using it, we gotta understand what makes this thing tick. So, if you look up the official definition, you'll see something like this. A list is a mutable, ordered sequence of elements. Now I know, that sounds a little academic, but trust me, two of those words, mutable and ordered, are the absolute keys to the kingdom. They are the secret sauce that makes lists so incredibly powerful.
Let's just unpack that really quick. Ordered is simple. It just means things stay in the exact order you put them in. The first item is always the first item. Indexed is how we get to them. We use their positions starting from 0, of course. Heterogeneous is just a fancy way of saying you can mix and match. You can throw integers, strings, whatever you want into the same list. But mutable, that is the real game changer. It means you can change the list after you've made it. That flexibility is what separates it from something like a string and what makes it so useful.
All right, enough theory. We know what a list is. Now let's get our hands dirty and see what we can actually do with them. We'll start with the basic toolkit. Just looking at our data, inspecting it, without actually changing anything yet.
And the great thing here is, this should all look super familiar if you've ever worked with strings. The plus sign, it just smashes two lists together to make a bigger one. The asterisk, it just repeats the items in a list. Now, one key thing to remember is that both of these operations create a brand new list. And then you have the in operator, which is like a little detective. It just peeks inside and tells you, yep, that item's in there, or nope, couldn't find it.
And this brings us to one of the most powerful inspection tools out there, slicing. Again, if you can slice a string, you already know how this works. You just give it a start and an endpoint and bam! Python carves out that piece and hands you a new, smaller list with just those items. And just like before, the original list is left completely safe and sound.
Okay, buckle up. This is a big moment. So far, we've only been looking at our lists from the outside. Now, we're gonna dive in and actually start changing them. This is where that whole mutability thing we talked about really comes to life.
So this is a classic stumbling block for so many people, but it's actually really simple when you see it laid out. Think of append as taking whatever you give it and sticking it on the end as a single item. So if you append another list, you get a list inside your list. It's like putting a whole box on a shelf. But extend is different. It's like opening up that box and putting each individual item on the shelf, one by one. Totally different results.
So adding stuff to the end is great, but what if you need more surgical precision? Well, we've got tools for that too. Insert lets you put an element at any specific position you want. And for taking things out, you've got two main choices. If you know the value of the thing you want to get rid of, use remove. If you know the position or the index of what you want to remove, use pop. And pop has this cool little bonus feature. It actually hands you back the item it just removed, which can be super handy.
Okay, so we've got a handle on how to create, read, and modify lists. Now we're gonna level up and get into some more advanced stuff, like how we organize the data inside them, and, this is a big one, how we handle copying them correctly.
Here we go, another one of those crucial distinctions, just like append versus extend. So, we've got sort and sorted. The list.sort method is a direct command. It messes with your original list and sorts it right there, in place. But the sorted function is much more polite. It takes your list, goes off and makes a brand new sorted copy, and then hands that copy back to you, leaving your original list completely untouched. So you always have to ask yourself, do I want to change my original list, or do I just need a new sorted version of it?
Now listen up, because this next concept is the source of some of the sneakiest bugs in Python. When you write list2 equals list1, your brain thinks you've made a copy. You have not. What you've made is an alias. Think of it like this. You've just given two different names to the exact same list. They're both pointing to the same object in memory. So if you change something using list2, you're also changing list1. What you usually want is a clone, a totally separate, independent copy.
So, how do we make that true independent copy? Well, you've got 3 main ways to do it. The full slice using : is a really common and easy trick. You can also just use the list function on your old list. Or for more complex situations, there's a whole copy module you can use. The bottom line is, all 3 of these will give you a brand new list so that any changes you make to the copy won't ever affect the original. Okay, let's tie all of this together now. We've talked about mutability, we've talked about copying. So what happens when we start passing lists as arguments into our functions? This is where all these concepts really come home to roost.
And here is the absolute key takeaway. When you pass a list to a function, you aren't passing a copy. You're passing a reference, basically the memory address of the original list. This means that the function has the power to reach back out and directly modify your original list. Now, that's incredibly efficient, and sometimes it's exactly what you want. But if you're not expecting it, it can be really surprising. It's a direct result of lists being mutable.
And that brings us to our final thought for today. We've spent all this time talking about how amazing it is that lists are so flexible and so changeable. They're a true programming powerhouse. But it kind of makes you wonder, right? If being mutable is so fantastic, why would you ever want to use a data structure that you can't change? Why would you want something that's locked down or immutable? Well, there are some very good reasons, and thinking about that is your next step on the road to truly mastering Python's data structures.